Hello, I'm Anthony Black, Superintendent of the Southeast Research and Education Center here at Midville, Georgia. I would like to welcome you to our 2021 Virtual Field Day. Back on August the 11th, we hosted an in-person event here at the center, and today's production is recording of those presentations. Whether you're viewing this for the first time, or you were back here in person on August 11th and just looking for some refresher information, I hope you find something useful today. As always, feel free to reach out to me at any time or visit your local county extension office. You can also visit our website, and a link will be included at the end of this presentation. Thank you for watching.
Okay, let's start then. And good morning, everyone. It's great to be here to talk with you about the soybean program and our soybean research. My name is Zhenglu Li. I'm a professor and a soybean breeder and the UGA. Also, I have Bryce Wilson, our research coordinator, come with me and to talk about the soybeans. So let me first start with the soybean breeding program. And we set our goal for the soybean research. And so we try to develop soybean cultivars adapted to the Southeast region. And with high yielding, certainly that's the goal, major goal for the soybean breeding. Also with the disease resistance, enhance the quality. That means high protein, high oil, the seed composition part. Also, we work on the herbicide tolerance. That's very important, and the nematode resistance and the drought tolerance. We develop the cultivars not only have a high yield, also have other trait. And so last year, we have over past the few years, we released the Roundup 2 soybean cultivars, also Liberty Link and soybean cultivars. Last year specifically, we released one soybean cultivar that's conventional. You can see yield performance compared with the Roundup 2 yield. Commercial tag is over 101 and to 110% yield advantage is in the maturity group 6. And so another 3 cultivars released last year is a high oleic, low linolenic soybean cultivars. Many of you may be aware of the soybean, the high oleic content. The normal soybean have an oleic content about 25%. This is the high oleic controlled by 2 genes can reach to 80%, over 75%. Generally, we have 80% oleic. Also, linolenic, we reduce it to less than 3%. That's kind of standard set by United Soybean Board. So the advantage for this, the high oleic, low linolenic soybean is improve the flavors for the soybean oil, also extend the shelf life for the soybean oil as well. Also, the restaurant can use this high oleic longer and for their process. So we released 3 high oleic cultivars last year. The first one is G15PR340. That's conventional. Okay, and also it's in the maturity group 6. Also have a really good package for the disease resistance. You can see that, and resistant to the southern root nematodes, also peanut root nematodes, Javanese root nematodes, plus SCN, soybean cyst nematode. That's important for the soybean production. The second one is high oleic soybean variety is in the maturity group 7. And you can see the fat acid profile 82.2%. Also, linolenic have 1.8%. So that's really good fat acid profile. Also have a good disease package as well. The third one is on the bottom is also the high oleic. Is in the maturity group 7 as well, but with herbicide tolerance. Roundup 1 gene there. Not only high oleic, but also have a herbicide tolerance. So you can see have a very good profile for the oleic and the linolenic. Also have a good disease package. Move forward, we have an agreement with the company to work on the new herbicide tolerance technology. The first one is we work with the Bayer Crop Science licensed called the Roundup to extend flex. That means have 3 mode of the action for the herbicide tolerance, include Roundup, glyphosate, glufosinate, and dicamba, sorry, not glufosinate, dicamba, and plus that glufosinate, and that's Liberty. So we, in the process, you can see next few years, we will have the new cultivar with Roundup to extend flex. And another trait we work on that herbicide tolerance is the enlist E3 soybean, and from Cultivar and MS technology. It's really new technology for the herbicide tolerance. And also have 3 genes called the molecular stack, include glyphosate, glufosinate, and 2,4-G. In next few years, we will have the new soybean cultivar released for the enlist E3 soybean as well. So in this field specifically, and the Midville station, we work on the soybean breeding for the soybean drought tolerance. What we try to do here is we try to screen the high yielding and advanced line and in this field. Those advanced line in the USDA uniform test or the state variety test. We want to grow the soybean and no irrigation condition. That means rain fade condition to evaluate the yield. But this year there not much stress. If we see there are lots of rains, that's good for the farmers. And also we do lots of the gene discovery and to identify the gene for the drought tolerance. Then we can incorporate those genes into our elite soybean germplasm to bring the soybean for the drought tolerance. As we know that irrigation is not a viable condition sometimes for the farmers, it's expensive. And so that means by bringing soybean for the drought tolerance, we hopefully could get better yield and rain fade condition. You can see there's pictures. We have the lines showing that called canopy wilting, slow canopy wilting. And in our breeding program, we use that line to integrate into our new germplasm to develop soybean cultivars. And also we try to use the new technology to develop the drought tolerance soybean. One technology we use that high throughput phenotyping with the drone. We want to look at that, the canopy wilting with the drone in the larger scale. Also, we look at the transpiration rate to see which line have a good transpiration rate and or good drought tolerance. That's in the process for that kind of research. So you again, I want to talk more about that field. You can see that is on this field, all advanced line grow in this field. You can see that we don't have any irrigation. And this year, the growth very well. Believe it or not, last year, we and no irrigation condition, we get over 100 bushels per acre. I talk about it's not a large scale. It's the plot yield. That's different from the farm's field production yield. So we really get good yield. This year we see the soybean grow very well, but no stress. So we will see the yield look like. So in the end, I want to thank the sponsor, United Soybean Board, for their funding support. Also, Georgia Soybean Commodity Commission for soybeans for their support, and Innovation Gateway and UGRAF and support that as well. Also, thanks for the GSDC, Georgia Seeds Development, for their support as well. And I also want to thank Anthony for their technical support and field support for our research. Really appreciate all your effort, great work. Thank you. Any questions, I will be glad to answer.
Good. My name's Mark Abney. I'm the peanut entomologist at the University of Georgia. It's good to be in Midville with a bunch of people again after being gone for a year. I get to go first at this stop, and I won't take up a whole lot of your time. I guess I'll start. This is a research field day. We'll talk about the research that we're doing here. If you look at your program, I believe it says lesser cornstalk borer management. Okay? My trial is over there where you just came from. And I would give any one of you today $10 a piece for every lesser cornstalk borer you can find in that field, up to 10, okay? And I don't think I'd owe anybody any money when it's all said and done. So what did Anthony and I do wrong? We set this thing up. We talked about it. Heck, we talked about it last fall. This is what we're going to do. This spring, we talked about it. This is what we're going to do. We're going to have a lesser cornstalk borer trial in East Georgia. It's important. We need to know what we can use to manage these insects. We did everything wrong if you want lesser cornstalk borers. We planted late. That's bad. If you don't want lessers, that's bad. We planted late. We had cover. What was it, rye?
It was behind oats.
It was oats, and we burned them. That's the worst thing you can do, right? You burn your cover. It attracts the moths. We did that. We planted late. The one thing we couldn't do is till the dirt. Lesser cornstalk borers like tilled dirt, and we couldn't do it. Why couldn't we do it? Because in May it was very different than it is now. What was it? It was dry. And if we had tilled the dirt before we planted, we wouldn't have had enough moisture to get the seed out of the ground. So basically, we did almost everything wrong if you're a grower, but everything right if you want to do a lesser cornstalk borer trial, and we got no lesser cornstalk borers down there. Why? It's too wet. You can do everything wrong, and sometimes things will work out. You can do everything right, and sometimes things won't work out, right? With insects, you just don't ever know for sure what you're going to get. So we've got this trial over there. It's beautiful. It's laid out. It's got plot stakes in it. It's even got some treatments in it. It does not have any lesser cornstalk borers, okay? So that's the last I'm going to talk about the research here at Midville today. I'm going to take the rest of my few minutes and talk about a little bit of update about insect management in Georgia in August and September, all right? Are there any peanut farmers here today that have a problem with insects in their peanuts right now? Probably not. There aren't many, right? We had early season tobacco budworm. We had some thrips pressure early, but since the middle of June, we have not had bad insect pressure in peanuts. Part of it is because it's raining, right? Lesser cornstalk borer is one of the worst problems we have. They don't like it wet. It's been wet all over the state. We don't have to deal with that, okay? Another one of the really bad problems we have is two-spotted spider mites. They like it dry. If it's wet, we don't have two-spotted spider mites, and so far we don't have them. Dr. Roberts tells me, and he might mention it, that there's some spider mites hanging out in cotton. It's wet, but they're there. If it stops raining now, and it doesn't rain for 3 or 4 weeks, we could expect to see mites start to show up in some peanut fields. Okay, so you need to be watching for that if it turns dry. I understand if it turns dry that you're going to have bigger problems than that, but it is something that we need to pay attention to. All right. There's a couple of things in the field right now that you might see. You might see the tips of peanut leaves near the edges of the field starting to turn yellow from hopper burn. Okay, that's from potato leaf hopper. We're not really terribly concerned about that until we start to see it spread. If it's starting to spread, you need to go in the field, you need to check and make sure that insect is still present. Because they can come in the field, they can damage the field, they can be gone. You don't want to spray a problem that's not a problem. If the insect's not there, you're not going to fix the yellow with an insecticide spray. The other thing you don't want to do is put manganese out thinking you got a nutrient deficiency when it's caused by insects. If you miss it, if you miss those potato leaf hoppers and your whole field turns yellow, it's not the end of the world. You can still make good peanuts. But we're in a year where we're fighting disease, right? We got leaf spot, we got white mold. We don't want any more stress on the foliage in August and early September than we have to have. So let's pay attention to those insects, and if we need to manage them, we'll do so. All right, the other thing you're going to be seeing now is three-cornered alfalfa hoppers, right? If you walk out in these fields, I promise you there's three-cornered alfalfa hoppers. I'm not too concerned about them. A lot of people are. A lot of people want to treat for them. The amount of injury that they cause, the amount of yield loss that you will see from three-cornered alfalfa hopper is barely enough to justify a very cheap insecticide application. The only very cheap insecticide application that you can apply is a pyrethroid. If you put that in a non-irrigated peanut field, you increase your risk of spider mites. No, it's not dry now, but if it turns off dry and you put that pyrethroid there, you risk mites. I wouldn't do that in my peanuts. If your peanuts are irrigated and you can kill three-cornered alfalfa hopper with a $3 or $4 pyrethroid and you've got a lot of them, go to it. I don't have a problem with that. Wouldn't make a special trip. I'd put it in with a fungicide, and that would be that. Okay? That's three-cornered alfalfa hopper. The big thing you may or may not see coming up the next few weeks is foliage-feeding caterpillars. It's been really light with foliage-feeding caterpillars to this point. Normally by now in South Georgia, we've got a lot of velvet bean caterpillars. I'm not seeing moths in my plots. I'm not hearing from agents or consultants about velvet beans, but they are starting to come into the state. Will they make it to you? I don't know. They got to migrate from south to north. I don't know, but we need to pay attention. That brings up the question of dimolin. How many of you put dimolin on your peanuts automatic? Okay? It's not a bad thing to do. It's a very good velvet bean caterpillar product. Okay, if you've got dimolin out there, you put 2 or 4 ounces around now or maybe 2 weeks ago, you probably don't have to worry about velvet bean. This is what you still have to worry about: soybean looper, corn earworm, tobacco budworm, fall army worm probably, and any other worm that might get in those peanuts. You've taken your velvet beans off the table, but you still have to be concerned about those other caterpillars. So don't forget about those peanuts and not look at them for caterpillars just because you've got a shot of Dimlin or two out there. Fall armyworm, okay? If y'all been reading the news, the ag news, you probably know that out in the Mid-South, they've got probably the worst fall armyworm infestation anybody that's alive today has ever seen, okay? Lots of them. They're eating up the rice. They're eating up the hay. They're eating stuff up. A lot of you that have hay may have sprayed for fall armyworms in the hay. I've not seen problems in peanuts yet. It doesn't mean it won't happen. It just means we need to pay attention, right? If we get them in the peanuts, we're going to have to do something about it. We don't want to figure out that we have fall armyworms in our peanuts after they've moved from this field to the next field and we got nothing but stems. Does that make sense, right? Okay, can you kill them with a pyrethroid? Maybe. Can you kill them with Dimlin? Maybe. The county agents that are here, the first people that use a pyrethroid in the peanuts for fall armyworm, if it works, you need to let everybody know. If it didn't work, you need to let everybody know so we don't make that mistake twice, okay? First person, try what you want. After that, we're going to go with what the data tell us. Apparently, they're not able to kill fall armyworms in Arkansas with pyrethroids this year. So we need to, there's a reason, I don't know, but we need to pay attention to that. I'm Philip Roberts, extension entomologist located in Tifton. And today I'll just talk a bit about cotton. And as Dr. Abney commented, I'll take a few moments and just talk about what exactly we're doing here, just right up here on the left. But since 2017, we've been evaluating all the different BT cotton trait packages. You've got Twin Link Plus, Wide Strike 3, Bollgard 2, Bollgard 3. And we also have a non-BT planted. We set those trials up here in Midville every year since 17. We also set them up in Plains as well as Tifton. And the reason we're doing that is because entomologists, when we get together from across the cotton belt, one of our greatest concerns is where we are with BT cottons in resistance development. Now, we've been planting BT cotton since 1996. That's the year I started at the University of Georgia. There are a lot of growers here who never grew non-BT cotton. And, you know, sometimes we forget how great a technology we have. But over time, since we planted the single gene Bollgard, industry added a second gene and now a third gene. And they did that for two reasons. If you think back when we grew 555, and if you really think it wasn't uncommon for us to treat corn earworms on Bollgard cotton when we had one gene. Would y'all agree? I mean, it wasn't uncommon. We sprayed cotton every year. Since we started planting 2-gene BT cottons and now 3-gene BT cottons, we have rarely treated corn earworm in the state of Georgia. That's not true in other parts of the country. If you go up into North Carolina, for example, or over in the Mid-South, they are routinely spraying 2-gene BT cottons. Actually, in the Mid-South, they trigger sprays of Prevathon based on an egg threshold. Why do they do that? The 2 genes aren't performing. Why are they not performing? It's because resistance is developing in corn earworm populations. What I can tell you for the state of Georgia, the very first gene that was put into BT cotton 25 years ago, corn earworm is highly resistant to that gene. So what's that mean? The first gene's just not doing much. So now our Bollgard 2 really has one active gene in it. It's more like a single gene BT cotton. Okay, you with me? So if you got 2-gene BT cottons, it's almost like a single gene. Now, what we've seen in the last 4 years is we have not had corn earworm pressure. I mean, I hadn't heard of any fields of cotton in the state of Georgia sprayed for corn earworm this year. Has anyone sprayed corn earworm in cotton this year? Probably not. But I can tell you, we know populations right here, we get caterpillars from here and get them tested.
they're highly resistant to the first gene. They're developing resistance to the second gene. So when you look at your cotton, if and when we ever have corn earworm pressure, you better be sure you're scouting that crop. None of these cottons are immune to corn earworm. I've seen corn earworm in 3-gene BT cotton this year. Not many, not enough to treat for, but it can happen. But we just haven't had the populations to see these problems like they have in other parts of the country. And why is that? Why don't we have corn earworms like some other parts of the country? It's something I think about all the time. And I think there are probably 2 primary reasons. Where do corn earworms come from when they come to cotton? Right here on this station. They're coming out of corn, okay? And if you look at where they have problems with corn earworm, their ratio of cotton to corn is much more similar than it is in Georgia. You know, we're probably 4-to-1 cotton to corn, and we just spread those corn earworms out over a lot more acres of cotton, and we dilute that population, and that's a good thing. The other thing that I think is important, if you look at these other parts of the country where they're having to treat corn earworms, is they have major issues with tarnished plant bug. Now this year, perhaps some of you treated tarnished plant bugs in your cotton. They're becoming a little more common, and that's got me concerned. But we know when plant bugs are a potential problem in June on squaring cotton, that's a very important time when beneficial insects are moving into that cotton and becoming established in a cotton field. That's one of the reasons we really want you to scout. Don't make automatic sprays for plant bugs. We need to conserve beneficial insects because they help us. Maybe it's coincidence where they have these big corn earworm problems that they just happen to have plant bugs, but I don't think so. We do a good job conserving beneficial insects, and they matter and they help us. It's almost like another mode of action out there working for us. And I don't know if a corn earworm can get resistant to a big-eyed bug, you know. So let's just make good decisions and keep scouting. But I just say that, you know, none of these cottons are immune. We put a lot of effort into just monitoring this every year, and you know, hopefully we're gonna stay in it. But again, pressure's been very low. I actually summarized the data, and I can't remember if I put it in your book, but the 3-gene BT cottons are about 99% control, what we've seen the last several years. Our 2 genes are about 93% control, the Twin Link and Bollgard 2. Wide Strike's a little less. Wide Strike's only giving us about 75% control. But again, there's different traits in all those different packages, and they perform a little differently. Okay, I'll just finish up with kind of what I've been getting calls on. You know, August, we're in stink bug time. Most of you guys are very comfortable in managing stink bugs. You know, it's been a long time since I went and looked at major problems where we made mistakes on stink bugs. To me, we almost overdo stink bugs in some situations. We have a lot of confidence in our thresholds. You know, again, let's scout and just treat when we have to. What I've been hearing is stink bugs are all over the board. Am I missing something from some scouts? There's just very little there. And you may be in the same county, not 10 miles away, and stink bug populations are heavy. That's why you just need to check all your fields. We need to protect developing bolls to they're at least 25 days of age. So that last boll that you plan to harvest, if it's 25 days of age, you pretty much can terminate your control for stink bugs. But other than that, believe it or not, as Dr. Abney mentioned, with all the rain, it's just amazing that I've got calls about spider mites. And this is primarily in the southwest corner of Georgia. But it's to the point now, at least in cotton, this rain just don't make mites go away anymore. But again, very few acres have been treated, but they are there. If we get dry, it's just something we need to keep an eye out for.
Glenn Harris, also Extension in Tifton, Soil Fertility. It's good to be back in Midville. I haven't been doing research up here in recent years, but came back this year and appreciate Anthony and Travis helping out. I have some peanut research on the other side of this corn, and then I also have some corn research through the woods over there. We can't really see them from this location well, but I'll tell you about them. And also, before I get too far, I also want to acknowledge my technician, Lindsay McDonald. I couldn't do this research without her. My student workers couldn't make it today. They're back in class at ABAC. But that's how we get things done. I'll start with the peanuts. You know, calcium's the biggest thing on peanut. UGA, we had the recommendation. You know, you look at your calcium level, calcium, potassium, and if you need it, we'd say you put 1,000 pounds of gypsum on. And I know sometimes growers, you know, you say, well, I'm not sure I really need it. I still want to put some, and I might put 700 or 800 pounds or whatever. But I found out last year that some of the private labs, they actually look at calcium, magnesium, and potassium combinations, and they will recommend anywhere from 300 pound up to about 1,500 pound. And I thought this was interesting. I thought it'd be, as far as I know, I'm not sure where that research came from, so I thought, well, that's a good researchable topic we need to confirm. So that's what I have in the backfield here. We have different rates. Not exactly sure how you spread 300 pounds of gypsum with a commercial spreader. We do all of our work on small plot by hand. We put these different rates out, and I don't really expect a lot of yield difference, especially between some of these rates. But one thing we are going to save a sample and shell and look at the calcium in the nut, because that will tell us if we get higher rates or not. So, yeah, I think it's working now. So that's the peanut. If you have any questions about that, be happy to talk about that. Cotton's probably more interesting and more to see right now. I have 2 trials over there. I have a fertilizing NPK by yield goal. I have done this in other parts of the state, but mostly Tifton and South, Camilla, Attapulgis, etc. And, you know, when I first started in 1994, we had one recommendation for cotton, for a bale and a half cotton. For example, nitrogen was 60 pounds. We worked on changing those recommendations. By 2000, we had yield goals for NP and K increases up to 3 bale cotton. Of course, what happened in the last couple of years, people say, well, what about 4 bale cotton? So, you know, we have to look at that. Anyway, we have to do this all by hand again. The location over there is high in phosphorus but low in potassium. So the nitrogen rates range from 60 to 135 pounds of N. That's the biggest differences. Phosphorus is only like from 20 to 50 pounds, and then potash 110 to 140. We put it all out by hand, and you wouldn't think you'd see a lot between these little differences, but Lindsay and I just drove by, and it's amazing. It looks like a checkerboard. You can really see it picking it up. We took tissue samples, and of course we'll take it through to yield. So one of the reasons I wanted to do that at this location is because I know variety testing, with Anthony's help, et cetera, they have been making really good yields. And believe it or not, I got about what we call 10 site years at different locations, and very few of them are up around that 3 or 4 bale mark. So I really wanted to do it here. So really interested to see what happens with that. The last study I want to talk to you about on cotton, you'll probably be interested in. You know, we've had a lot of potassium problems on cotton, and a lot of people like to split apply their potassium like they do nitrogen, some at planting, some at side dress. In the past, I have not seen an increase by doing that. So I wanted to do it up here, and we have called for 125 pounds of K2O. So we put it all at planting, all at side dress. We split it half and half, and we also did a 90 pound at planting and 30 at side dress. Again, I wish I could show you, and I should have pulled up some plants, Anthony. You can tell that's a low potash field. You can really see some severe potash deficiency in the low potash plots, et cetera. So really interesting to see how that's going to work out too. I'll finish like Philip did, just fielding some questions, telling you what's going on with all the rain. And I don't know if you've had as much up here as we've had down in the Tifton, and certainly Moultrie. I got some plots at Moultrie that have ducks swimming in them right now. Lindsay tells me that's not a joke. That's for real. What about this yellow cotton? Did I lose all my fertilizer? What do I do? And really, you got a couple of situations going on cotton, I think. The early planted cotton seems to look better than the late planted. And if hopefully you got side dressed on your early planted cotton, it's not looking too bad. If it turns yellow, we can foliar feed that out. Because the rule of thumb is once you get the third week of bloom, don't put any more nitrogen on the ground, switch to foliar. But the later planted cotton is the one that looks like it's really struggling, and a lot of it, we haven't got a chance to even get the nitrogen out there. And what do you do when you get the third week of bloom and you haven't put any nitrogen in there? You still need to probably put some on the ground. You can't really foliar feed that out. If you had on that late planted cotton, got your side dress out, again, I think you just switch to foliar at some point. I'm afraid now we're going to run out of time on some of this cotton. It was slow. It sat there wet, slow to pick up the nitrogen, and we're going to run out of time on the tail end. But remember, that third week of bloom is the normal time we switch to foliar. So, and we can foliar feed N and K. Other things, it's a little hard to foliar feed. So with that, I'll finish and see if you have any questions. Yep. 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 Great question. The question, do we have any foliar K on these plots? At this location and being far away, and I did not have the space to put the foliar treatment in, but I have 2 other locations with a similar study where we are putting foliar. Yes. You know, traditionally for potassium, I like potassium nitrate, 10 pounds per acre in at least 10 gallons of water. I know sometimes it's hard to get. There's a lot of other materials out there. But you start getting down around 1 quart of anything, I question how much potassium you're really getting out there. So probably my next product of choice after potassium nitrate would be potassium thiosulfate liquid, about 1.5 gallons in 10 gallons of water. And that gives you a good, decent shot, about 5 pounds of K2O. Yep. And you might have to do it twice, too. You might, it depends on how severe, how much you think you need. I'd do it at least once, maybe twice. About a week apart. Yep. Yeah. Yep. It's not automatics. No. Yep. Good questions. Any others? Foliar feeding is an interesting topic.
Dr. Harris, I would like to mention if there's any of you who'd like to see this trial, we just couldn't get over there with logistics with everything else, but we can have a tram available right after lunch. If a group of y'all would like to go over there, I'm sure that's something that wouldn't be hard to do.
I got the plot plan in my pocket, and I got Lindsay here with me so we can answer your questions. Sounds good. It is, actually. It's got a thick cover of rye.
Heavy rye.
Heavy rye. Yeah. Yep, good question. I thought I saw another one over here. No?
Magnesium levels on cotton. Putting 100 pound of K-mag out, and the video was still saying you're not in the adequate zone for magnesium. Should we up our K-mag next year?
I'm not too concerned with magnesium on cotton. In fact, actually, it must not have been through UGA because we don't even measure magnesium in the petiole anymore. We just saw so few problems. So, you know, I'd like to look at, you know, and I like to look at tissue rather than petiole on cotton to try to figure that out. If you're liming with dolomitic lime, need where you need to be and using some K-mag, you really shouldn't be having any magnesium problems on cotton. Yeah, the byproduct lime does not have magnesium. That's correct. It's a calcitic lime. So, Epsom salts, magnesium sulfate sprays is probably the best thing to do in that situation. So, I mean, yeah, K-mag, but don't do it too late. I mean, I'd want to put it out there probably by side dressing time. Yep, good question. Yeah. That is correct. The question was, if you take, when you go to petiole, if you yank the petiole and the leaf blade, we call it, at the same time, and don't detach them. And my crew kind of hates me, but you know, I tell them you got to get them detached as fast as you can. We take them right from the field into the air conditioner and take them out because you will get nutrients transferred as they sit there. So if you're going to get a petiole, you need to get that blade off as soon as you can. Good point. That is correct. That's not a myth, actually. That's for real.
Dr. Henry Sintin. I'm a soil fertility specialist. Dr. I don't know, maybe you've met Dr. Glenn Harris already. So he's also our soil fertility. And we are all based in the Tifton campus. I'll be talking to you briefly about 2 studies that I have ongoing here. But to give a recap of the studies, let's talk about Georgia and the soils we have here. You know our climate, we say is subtropical. And what that does is it means we have intensive weathering of our soil. It's raining, leaching important base cations from our soil. And then you have sun and then moisture, right? So you have all the organic matter in the soil that is warmed up and it's mineralized, or to put it in a simple way, we would say decomposition. It's so high. So how, as you all know, that when you pick a soil, you expect that about 5% would be organic matter. What is the organic matter we have here in Georgia? If you've been taking your soil for analysis, you measure what the organic matter come out to be. Maybe 1, sometimes as low as, sometimes below 0.5. So what that tells us is we have a highly weathered and very unfertile soil. So for a very productive row crop production, to be very productive, to have a successful crop production, 2 things come to play. You need to be very, very attentive, right? It requires intensive nutrient management. So in order to address that, because if let's say we go to the Midwest where they have most molly soils, those soils are very fertile. They can even grow dryland corn and still make about 200 bushels. If you come to Georgia, especially if you go down south, you're trying to do dryland, you might be lucky if you make 50 bushels, right? And it's all because of the native fertility of our soil. So one of the objectives of my study or my program is how can we improve the soil health of our soils in Georgia. And as you can tell, I'm also looking at different aspects of the state. So in here southeast, and I have studies here at the station, looking at, you might have heard the term regenerative agricultural practice. It is kind of a conservation management system that you are trying to reduce disturbance to the soil by adopting some practices like cover crops, minimum tillage or reduced tillage, sometimes just strip tillage. You don't want to disturb the soil too much. And also we have rotation, we have organic amendments, we have chicken litter. Georgia still reigns as #1 broiler production in this country. That means that we have access to broiler litter. We can make use of that and use that as an amendment. But the question we are trying to answer is that when you adopt a single practice, let's say, I know some folks that have been doing cover crop for several years, and they are beginning to question whether it's really beneficial because the build-up is so slow in terms of improving soil health. So the question was thrown to us. Can I adopt multiple management practices, and will that improve my soil health faster? So that is the intent of the study. You just pass by it. As you know, for row crops, we have corn, cotton, peanut as the dominant row crop system. So, and that is what we are testing here. We have row crop system, and we are looking at integrated management practices or regenerative agricultural practices. So we have a system where we are doing no cover crop, conventional tillage system, and also no amendment. And in another treatment plots, we have we are practicing only cover crop just reduced tillage. We just strip till those fields. And then another one we do strip till, and then we grow cover crop on top of it. And then we do strip till, cover crop, and then we apply chicken litter. As I already mentioned, our climate, subtropical, right? High temperature and very wet conditions. That are a recipe for high mineralization potential. So it means that the chicken litter don't stay in the soil to build organic matter that long. Now, there is that advocacy for adding stable organic matter, like biochar. So we are also looking at another treatment where we look at reduced tillage. The reduced tillage, we are talking about just straight strip till. And then we have cover crop, then we have chicken litter, and then we have the biochar to see how we have all these integrated management systems, and we are quantifying the impact on crop yield, productivity, quality. We measure all that. And also, we will look at the soil health, measure, we pull soil samples every year, and then analyze the state of the soil. This is not a good time for me to go into how we quantify soil health. It's a soil health research. I wish I had spoken about how we are doing the soil health quantification. But in short, we are measuring physical, chemical, and biological indicators. So for biology, you have soil respiration and enzymes and all the microbes. We do that. And also for physical, we are looking at bulk density, soil resistance to penetration, which mimic how the roots easily grow through the soil profiles, or whether there is a hard pan that is impeding their growth. Chemical, we are doing all the fertility, right? All the nutrients that you can think about, and also like pH, cation exchange capacity, which are important indicators. So if you combine all these, the middle center, the center point becomes soil health. But so enough, that is where I would leave the soil health study. Let me switch to the fertility trial, and then if there are any questions, I'll be happy to take. I have already established that you need to be on top of your nutrient management program in order to have a good crop. If you go to trials and I show you the control plot, you'll be like, oh, wow. I always say that if you look at those plots, then I tell you that's the benefit of your nutrient management program, or that's the benefit of your fertility. You can hardly get anything with the type of soils we have here. So we have a cotton trial that was proudly sponsored by the Georgia Cotton Commission. And we are looking at how do cotton respond to different nutrient stress conditions or nutrient management conditions. The goal is that we want to be able to develop the best diagnostic method for cotton, and also see whether we can push the yield, nutrient recommendation for higher cotton yield. We have recommendations to 3 bill, and previous work done by my colleague, Dr. Glenn Harris, shows that up to the 3 bill, you're still making a net profit. The return on investment was positive. So it means we might be able to push to 3.5 to 4 bill. So that's the goal, and fertility become critical. So that study is looking at various management practices. We have one treatment. We just put out 40% of the recommended nutrient to the soil, and then we expected crop to take it. But then we expected to undergo late season stress, meaning that, and we are pulling tissue samples. We are taking it from the leaves, from the stems, and also from the reproductive tissues. So as we are doing this over time, we're able to tell which nutrients are culprits, and how do we quickly, and which of the parts of the plant would be good indicator for making recommendation for diagnosing nutrient deficiency in your crop. Another treatment, we did not put out any fertilizer at the early stage of the growing season till the square stage. And at the square stage, we put fertilizer out. All the recommended nutrient applications, split it 50% at the square stage, and another 50% between the second and third week of bloom. So in that instance, what are we going to know? Okay, the plant is already stressed nutritionally, but as we put out the fertilizer, which parts of the crop was able to detect the nutrients in that uptake? Because we are doing this over time, right? We have a time series. And so that gives us a better understanding. We are basically mapping nutrient uptake in the crop. And then another treatment where we are really shooting for higher yield, but also we are trying to put out the nutrients periodically. So we put 40% at initial stages of planting, another 30 between the square stage, and another 30 between the second and third week of bloom. It turned out this year, last year it didn't really matter, but this year it turned out to work out very well. Why? Very, very high rainfall. If you go to our Camela, we have this trial also going out in Camela. And if you go to Camela, you realize that the soils are more sandier. So with all the rains we've been getting this year, it's leached most of the nutrients, the mobile nutrients. Talking about nitrogen, these boron and others. And even more importantly, you wouldn't think potassium goes away, but this year we are detecting it. And we put soil samples from the 0 to 6, 6 to 12, and 12 to 18 inches. And then overall, we have a control treatment. And in that control treatment, we are using standard nutrient recommendation for making trade bills. I prepared some handouts. I guess you all have received the brochure. Please, you can read that. I have my contact information in there if you need further information. I'm also happy to come to your fields, work with your agents to come to your fields for any interactions and also observations of your field, any form of interaction that would help you make the best crop that you so desire. I'm excited to share with you. This is the second year. For the nutrients, soil health is the first year, so we don't have any preliminary data. But for the nutrient study, I want to tell you that what we observed was that cotton is able to tolerate early season nutrient stress. The plots, if you, and so meaning but then the late season stress was just terrible. Of all things you do, but overall the best is when you make nutrient available to the crop over the growing season. This year, I expect the results to be slightly different just because of the amount of rain we've had and the leaching that is going on. So my recommendation is please stay on top of your nutrient application. And also, don't slack during the late season too. Try to make sure that your crop is nutritionally, we have in the website, the UGA website, the Agricultural Environmental Service Laboratory website, we have a recommendation of where you ought to be. So if you are observing deficiency symptoms and all that, please pull tissue sample, pull soil sample, do diagnostics, and make timely correction if you can. So I'll end here, and I will open up for questions if you have. Yes, please. Before we plant cotton. I think this year we did about 2 weeks, right? Yeah, about 2 weeks. We did about 2 weeks. We did straight rye. Just rye. I know there are more questions coming up, and if Peyton Sapp is here, he probably will tell you about different cover crops he's doing. There's another study out down here. As you go, you make round the trip. There's another study down there that I believe there is a presenter down there that will tell you about the effects of different cover crop. He's looking at mixed cover crop, rye, clover, all these nuances of, we want to add nutrient, or should we build by using high biomass cover crop like rye, or should I use a leguminous base? Should I mix them and achieve multiple goals or purpose in just one cover crop planting? So I'm excited about that study. And I've been involved. It's in this 4th year, and I believe when you go there, you get more insight on that results. Any further questions? I guess I'm running out of time. All right, Anthony is just giving me the signal. So once again, thank you all very much, and I'm happy to share more results as they come in. Look forward to the data. Thank you.
My name is Simmerwork. I'm an extension precision ag specialist. Between Wes and I, we cover different areas on the precision ag side. If you remember me from my earlier talks, probably from some of the planter work I did earlier, lately been focusing in my position here a lot of for fertilizer application, I would say technologies or equipment, and also some of the spray application technologies, PWM or nozzles and all that. So I'm going to just I got a lot of trials here with Anthony this year, given the first year I'm in this position. We just kind of went out, try to do everything. So I'll give a little brief update on everything we're doing. I think first I kind of want to thank Anthony and his crew for being supportive of our work, and also making sure that he was very willing to adopt some of the precision ag work we kind of talked about last year. I think one of the things, recent addition, is that buggy with the variable rate fertilizer capabilities that he's implementing, and then also some of the other stuff we're talking about, sprayer here. I guess before I start talking about the fertilizer application and the sprayer, how many of y'all have your own fertilizer sprayers? How many of y'all get the commercial applicators to come do it? What's the biggest problem with a broadcast sprayer like that? One issue. one issue. What would be? Okay. What about the spread uniformity? Pattern, right? One of the biggest problems with these is trying to calibrate them, and every time you change a setting or every time you try to spread a different blend or something, you need to calibrate it again and again, right? I mean, there's no way around it. It's I would say a fast and efficient way of getting the fertilizer out, but it also not, sometimes you can see a lot of streaking and all that just because of the pattern, not the uniformity there. So one of the trials which me, Dr. Corey Brand, our corn agronomist, and Dr. Glenn Harris, we kind of doing here this year. This is one of the locations, and we got one in Tifton. There are a few other different application methods, I would say, out there. One of them is, I don't know how many of you heard about Soil Warrior. So if you look it up on their website, it's actually almost like a strip till machine with the tubes coming behind the strip till, the shanks, and it's banding fertilizer behind the rig, and has been pretty famous, I would say, in the Midwest. A lot of growers kind of swear by it, started using it. We actually have a couple of the high-yielding growers corn growers in Georgia that have it, so that kind of piqued our interest on, is there any benefits, yield advantage by doing it. And then the other application equipment that you probably see, so that's a subsurface banding, right? The other, which is again a broadcast, how many of you have seen the air or boom spreaders? Right? AGCO almost looks very similar to a sprayer, but it actually has drop tubes. And instead of broadcasting, it's again banding, but more so fertilizer, on the surface. Some of the, I guess, feedback I've gotten from some growers who have used it, that we don't have a lot of those in Georgia, more so in Florida or Midwest again, is it's very accurate compared to the broadcast, but again, there's a lot of moving parts or all that. So one of our projects, again, coming back to, is comparing those three application methods in corn at two different rates. So we got a study here where, again, given the plot scale research, we didn't exactly use, the big equipment or get the Soil Warrior, which only comes in a 12 or 16 row. So we actually had a 2-row strip till rig. If you look in the field day booklet, you see the picture on the very end of the projects there that we took a strip till rig, put a first grains bin there with a fertilizer grain, it's a fertilizer drill on it, and then put the tubes where it's banding fertilizer behind the shanks. So we're doing the subsurface banding, and then we also had it changed where it don't band behind or subsurface, it only kind of bands on the surface to kind of simulate more like that boom spreader. And then we had our buggy, obviously, to kind of simulate the broadcast. We did two different application rates for two different yield goals. Again, this is the first year we're doing this study. From what we have seen so far, obviously we got a lot of difference in the low rate and the high rate, but we also seeing some differences in the banding versus broadcasting. Where we're pulling tissue samples every 2 weeks. We're about close to harvest here in 2 or 3 weeks here, so we should have the yield data out of that. I don't want to say anything about one method better than the other without looking at the data summarized or have all the data together for both. So that's one of the projects we're working on. The second one, more on the precision placement side, is how many of y'all have heard about Y drops for nitrogen? Anybody using it? Okay, so that's the second thing we're evaluating here. Again, something that's been becoming a little bit more, popular if you're doing a lot of nitrogen placement, type of work, along with timing. It's basically like, again, I got a picture in the field day book there of one of the wire drops, where it's basically, it gives you precision. You can precisely place the nitrogen, in the row next to the corn, 4 inches, 6 inches, whatever you want to. So first year, me and Anthony kind of talked about it. He had this side dress rig where he had the center tubes that most of our growers do, or he had one where we also had two in one row, feeding each row, and a skip row, and then two. And then we kind of took the side dress rig he had and turned the nozzles on that, and we made it almost a simulated wide drop. So the first year we're doing is we're just kind of simulating. We don't have a true wide drop here. Actually, I see Josh in the crowd. We do have the wide drops at the Iron Horse Farm. So we're doing a kind of identical study there. But our plan here is we're collecting that data to see if those wide drops provide the precision placement with those provides any benefit, you know, in the yield, or we also did some tissue samples in that. But next year our plan is to bring the true wide drops and equip it on one of the sprayers here, hopefully a 4 or 6 row, and be able to do a study with the true wide drop. The biggest thing right now is each piece is about $250 or $300, you know, so there has to be a significant yield advantage for us to kind of show the value behind it. So those were some of the fertilizer application. Also working, like I said, closely with Anthony on doing some variable rate fertilizer work here just in general for his fields, coming up with different strategies, especially in cotton, you know. Do you do a single blend and then go back with just a P, or to go back just with a K? So kind of looking at different strategies we'll implement here next year. The second area I'm focusing on is a little bit, like I said, on the spray technology work, both in peanuts and cotton. The field back there is actually one of our peanut trials. We got trials all over the state just looking at different things. First year, I'm just kind of focusing early on. One of the most common questions, and even though I'm focusing more on the technology I got from the growers, is the nozzle type or nozzle selection, because there's just so much emphasis on getting the right droplet, especially if you're spraying cotton. You know, some of the drift concerns, you need to use those oxygen or dicamba tips, all that. So some of the work we're doing is different nozzle types, creating fine or medium droplets, and then some were about very coarse droplets, and then using the dicamba tips. More or so, if a grower has to use one tip, we also have some growers with cotton and peanuts who just like to stick with one nozzle between both systems, you know. So we're trying to see, are those larger droplets impacting any of the peanut pest management in a small plot. We're also doing some stuff with Dr. Eric Prosco on some of the large farms. And then something we did, which is a pretty visual, clean visual again in the book here, is just the value of rate controller. You know, I believe every sprayer today has it, but if you don't have it, because a lot of our growers have 2 sprayers actually, one for the cotton and sometimes one for the peanuts, you know. So we actually turned the rate controller off and just did some speed stuff with where we calibrated the sprayer at 6 miles, 20 gallons, right? And then we start going up 2 miles at a time, 8, 10, 12, 14, and 16. I wanted to go to 20. I don't know where Travis is, but he said he's just not comfortable doing that with the tractor there. But even if you saw going from 6 to 10, instead of putting the first thing or 20 gallons, we were down to 12 or 13 gallons. But if you look at the image that I have in there, just the decrease in the coverage, right? The most decreased coverage we saw was again for the medium droplets. And the reason being, there's just so many fines in that droplet that all of that at higher speeds are just getting drifted away, right? So just the value of a simple technology like a rate controller, which we highly recommend, you know. We're also working a good bit with the PWM technologies and all that. Something I just want to mention real quick, because I remember helping a couple growers in this side of the state with some nozzle selection. If you do have a PWM system on your sprayers and you're using the air induction tips, on those, some of the air induction tips are not compatible with the PWM system, just because the pulsing and the way they're pulling the air to create larger droplets is not compatible. So make sure you're checking with your company rep or whoever's supplying you tips, you know, or feel free to call us to kind of help. But make sure you're checking that instead of not making a application again having drift concern or something. So. And the last thing I want to mention real quick, we're also doing some stuff in cotton with a hooded sprayer. If you guys saw in front of the shop here while we were having lunch, you see an open boom and a hooded boom sprayer. Is just, I guess I learned a lot about all the challenges. Every time we talk to growers about, you know, a hooded sprayer, we personally kind of felt the challenges. It's not something, a permanent solution, just because a lot of inconvenience that a hood brings into, right? But we're just trying to collect some data, how much drift reduction are we achieving with the hood? Is that a viable solution or not in cotton? So we're doing it at different stages just to kind of see. So we'll have that data at the end of this year as well. Anybody got any questions on me before I kind of pass it on to Wes Group to talk about some planter stuff? Uh-huh. Same amount early on. So research suggests, again from the Midwest, that banding not only improved the corn yield, but also they were able to lower the application rate about 25%. Our first year goal was just to do a side-by-side comparison of the same rate to see does banding have effect or not, but we also have a lower rate and a higher rate. So if I think it does have a little bit of effect, we may be able to see that as well.
Also on the sprayer tip selection, speaking with foliar fertilizer, right now for me at least,
Bluetooth pairing.
Mm-hmm. Okay. What? How tall is the cotton? Okay. How high is your boom? Okay. I haven't done a whole lot. Well, I collected some data in cotton doing a foliar application. Not a lot of replicated, but we collected a bunch of data in peanuts, especially when you're doing stuff like that for like a canopy penetration and coverage. Can you achieve when there's a lot of foliage there? Something that I noticed is it is better, instead of running a higher orifice, let's just take example 04 and a lower pressure, right, 30 or 30, what we have seen gives a little bit better coverage and penetration is going down a size on the tip, but up your pressure, so you're spraying the same gallons per acre, but you're actually forcing more spray, into the canopy for a better application, or to the ground, to make it to the ground. A lot of application, and that's why there's a lot of drop nozzles and stuff like that in the season for, some growers are doing. But when there's enough canopy and they're spraying anything on the top, do you want it to make it to the bottom or not? It really depends on that. It's just too. Is it, what are you spraying again? Fertilizer. Dr. Harris, does that have to go to the soil to get into the plant?
No, he's right. You want it on the leaf. I'd go with a smaller personally. Yeah, I think.
If coverage is your goal, I was getting at, is coverage a goal there? So if coverage is a goal, you do want, again, use a smaller tip to get a better, finer, medium droplets to get a more coverage instead of a higher orifice and smaller pressure and larger droplets.
Good morning, everybody. I'm Andrew Russell, one of Dr. Wes Porter's master students working on planter trials here. Sort of going back to basics with this one, all we used is just a normal monosim ground-driven planter and looking at combinations of speed and downforce with peanuts and cotton. With peanuts, the results are about what you'd expect. You have to go low and slow with them. You're a large, heavy seed at a high population. If you get much higher than 3 miles an hour, you're basically making peanut butter in those hoppers. But with cotton, you're able to bump it up a little. And this brings me to the next section, the downforce. It really helps to have that just moderate downforce for both your cotton and peanuts. It helps stop that bouncing in the row units and keeps your seeds at the depth you're trying to get, so you have your uniform emergence, which helps through the season. Yeah, just a standard ground-driven planter. Take it easy with peanuts and keep your downforce on there. You'll get some better emergence there. Moderate downforce with peanuts was 200 and 100 with cotton. We did 0 downforce, 100 pounds and 200 pounds for cotton, and then 0 pounds, 200, and 400 for peanuts. If you have any cover, crusting, clods, you definitely want to keep that downforce on there, otherwise your Rona units would be all over the place.
Good morning, everybody. My name is Luke Fuhrer. I am a master's student under Dr. Wesley Porter. This year, actually here at Midville Station, we're actually working on an irrigation project. God blessed our growers this season with a wet. As you saw, most of the talks before us, they mentioned the fact that it was a wet year. So for irrigation studies, probably not the best year to do test on those, I will admit. I think we just finally irrigated for the first time, I think Monday morning. We finally irrigated. But that's okay, because overall, that helps our growers and that keeps money in y'all's pockets, and that's at the end of the day, that's important to us. Currently over here, we're evaluating 2 different scheduling methods for that. Of course, scheduling is extremely important when it comes to irrigation. This needs to be based off of something. You need to base it off of weather, rainfall. You can run it off the checkbook method as that. All that is just a historical record. And based off of that, it tells you as your crop progresses how much water it needs per week. We're also running, though, the Lindsay FieldNet system, which is actually a online system that has a model built into it. You put in your planting date, you can put in soil textures, you put in your variety that you plant, and all of that will go into that model, and it actually presents us with a graphical model along the way. And as your season progresses, it gives us a graph of how your water refill level is in the soil is looking. We're of course confirming that with watermark sensors currently. We're actually working with a new type of sensor or a new housing right now with the Realm 5. We're using their flip model. Seeing some pretty good results out of that. With that being said also though, we're still kind of evaluating the Lindsay model right now. It's pretty nice. Honestly, everybody nowadays has these. It's very nice to have. I know I depend on it a lot myself. We're able, of course, as many of the newer systems, we're able to turn that pivot on and off. But along with that, we're also actually able to see how our crop refill level is when it comes to what the model is predicting. So this model, how it actually builds this model is it uses, of course, your temperature. It of course has your crop growth stage. It takes that into effect, but it also takes into the fact rainfall. We're blessed here on the station. We have a rainfall station. So I'm actually able to get in what the actual rainfall for this specific area is. But the model also goes in and uses a predictive algorithm with it where it's based off of cloud cover. So of course this can be kind of a double-edged sword. Some days it really hits it on. It's pretty close. I know this morning before I left it said that we had about 1/10 of an acre here, which in reality yesterday they didn't see any rain here. So, and again, sometimes it's better than others. So currently we're kind of evaluating that against the standard UGA checkbook, which is currently kind of the method UGA is kind of back at the moment. Just trying to see what different tools we have out there for Georgia growers. Like I said, hopefully we'll actually see some results now. We're going to keep going with it. I know we're still kind of looking at it. I know Anthony and I have had a few hiccups actually here recently, but it creates a new plan every day for us, and we're going to continue to evaluate that and see how it goes and run this, of course, through the end of the season. If we have any questions, we can take questions or...
Good morning, everybody. Well, the experimental field we have here, which is these little chessboard-like design of peanuts. What we're doing is we're bringing in very strong pest and disease resistances from wild species into the peanut crop. And we're doing that using crossing schemes with wild species. The story of why peanut needs these crosses or would benefit from these crosses starts a long time ago, between 5,000 and 10,000 years ago in South America, when the peoples who were migrating up and down the eastern border of the Andes in Bolivia and Argentina, they started using wild peanuts as a food source. And as they moved, they would plant the excess ones, so they would return back in a year's time and collect them. And what happened at one point was they planted two species together that don't normally grow together. And that formed a hybrid. And from that hybrid, all of the world's field peanuts are derived from probably an individual hybrid. So the genetic diversity in the peanut crop is very, very small. And that means that it's very, very susceptible to diseases and pests. And there are very few sources of strong resistance within pure pedigree peanut. So what we do is we go back to the species from South America. There are about 30 species. We've ordered them out in a sort of tree of genetic relationships, and we are selecting them along that tree to make a complex hybrid which involves hybridizing two types of wild species, just like the original hybrid that gave peanut was, between what we call an A and a B genome species, doubling the chromosomes, and then we can hybridize them with peanut. Then we do a series of genetic steps. We map the resistances of interest. We maintain them using DNA marker selection, which is a bit like a 23andMe. We maintain them down the generations, and we recover the elite field performance that you expect. So if you see close in the field here, we've got some plants which are flowering very profusely. Those are our first generation tetraploids, hybrids between two wilds that have got the chromosomes doubled. And then further back, what we have is we have families of plants. There are 12 individual plants within each individual square. And the reason we plant them individually is so that we can sample their DNA individually and observe them individually. And that's the way we do the genetics. And then on the end of the block, there's a little row which shows us how they grow under more normal field conditions. In the very far, these plants that are close to us, they're between 2 and 10% wild. That makes them, well, obviously 98 to 90% cultivated. Those little bits of wild genetic information that come in, that brings in, within the little pieces, about 100 times more genetic variation than you see between any two peanuts anywhere in the world. So they bring in a lot of variation. These plants closest, they have a new source of root knot nematode resistance, which is completely different to the one that's currently available in varieties like TIFNV and 14N. It comes from a species called Arachistenospoma. We're testing that also in Tifton. It also brings in new sources of resistance to late and early leaf spot and rust fungus, which we're genetically characterizing at the moment. Going a little bit further back into the field, we have plants which we're combining resistances from a species called Arachistenospoma against early leaf spot, late leaf spot, and rust. So these plants, they're still genetically segregating, so it takes a little while to fix that. Some of the most highly performing, we hope that they may make cultivars. We work closely with breeders so that they can also incorporate this genetics. And the other thing that we do is we, together with the genetic characterization, we make selections which are then deposited in the USDA germplasm collection. They have all the genetic information, their pedigree information, and so that will serve as a permanent genetic reservoir for any new traits that are being looked for in the future. So in that way, we hope that this new collection that we're creating will be useful for decades to come. Thanks very much for your attention. If you have any questions, fire away.
Okay, thank you. Yeah, so 6 foot squares. 6 foot squares. So every square has at least one plant in it, divided into 3 main families. The first one here, which is probably a
about half of that number, so maybe 2,000 individual plants. Oh, thank you.
So maybe about 2,000 individual plants. And they represent about 100 different families. And in the next one, we have probably about 1,000, and in the next one we have about 1,000. They're structured into families, so out of those, we'll be selecting only the best ones will go to varieties. I hope that helps. I'm not sure if that was the answer you're looking for. Well, this material here, it's almost fixed. So to be really fixed, we'd want it to be in the 6th generation. The material here is in 4th generation, so it's quite fixed. We have replicates of the best performing lines here in Tifton and in Raleigh in North Carolina. So clearly they're small blocks, but we are already comparing their performance in different locations. Yes. So we've been using a combination of different varieties and breeding lines. So we've used the top breeding lines which will still be released from the USDA program from Corley. So we use quite a lot of Corley's material, and we use quite a lot of material from Bill Branch. So 06G being so popular, we're incorporating that as well. What we do in terms of genetics, it would be cleanest if we were to always use the same cultivar at each generation, because it involves crossing back. But we don't do that. We try to accumulate the benefits of the different cultivated lines by swapping them between generations, so they have complex pedigrees. We get more variation that way, and hopefully we can select better material out of it.
All of this was hand planted, so each square
Yes.
had a person in it, when it was established, and then each square will be hand harvested. We'll actually take an inverter frame with feet on it but no chain, and we'll cut under, but each square will have to be lifted and brought back up here, and then actually thrashed by hand. You got a piece of the standard metal grating, and you just rub the plant over it. So each square can be potentially collected individually.
Yes, it's every single plant in this, which is about 4,000 plants, as Anthony pointed out, is planted by hand. It takes it took us about I think there were about 14 of us. It took us the whole day, and what we do is we line up all of the material, individual envelopes in order, and then parcel it out, and it's all planted by hand. But we need to do that because in these early generations, every single plant is genetically unique. So we can't plant it in rows, otherwise we wouldn't be able to go back and see which each plant does.
Good morning, everybody. I'm gonna let them come on up just a little bit, and then we'll start talking. Can you believe we got a little bit of sunshine for the first time in what, a week? Last 2 days? 3 days? Can you hear me? There you go. All right. So a lot of sunshine. We need a lot of sunshine. Again, I'm Scott Mumford. I'm the peanut agronomist with the University of Georgia here at Tifton, or not here, but at Tifton. Glad to be back up with you guys. This is one of 10 trials that we have throughout the state. It's a variety trial, but it's of the top varieties that we have out there commercially right now. Several of you guys may be looking at some of the newer ones like 16HO, and a few maybe the 18RU. The newest one that we have out here is Georgia 20 VHO, and we'll go through that here in a minute. I do want to kind of give you a little bit of an update on the crop itself, which if you're in your field, you kind of know what's going on there. But all over the state, we have
we've had a pretty decent season compared to other crops. We look pretty right now. Doesn't mean that we don't have issues. We've had a lot of our counties throughout the state had anywhere from, I think, 15 to 30-something inches of rain, if not more, in some of these counties in the last 2 to 3 months. I said back in the middle to late part of late part of May, that we probably had some of the prettiest stands that we've had in 10 years. And if you just go back 2 years, last year, what did we have? Some of the worst stands we've ever had. That was a lot because of germ and seed quality. This year, that was not an issue. And so we got a very good start for the most part. We did have some bumps and bruises through late April and into May with the weather. That did push us back a little bit. We have planted peanuts from South Georgia that go from April the 1st to anywhere up through here, all the way up to July the 10th. So we've got a big window of production here. These things are just now starting to get what we consider our normal summer temperatures that we need to drive this crop. We had a fairly mild June and July. Not bad. We're still accumulating heat, but it was cooler. The one good thing there, along with all the rain, is that we have set a pretty decent root crop. And if you look out on the limbs, we're setting stuff right now. The problem is all the rain and cloudy weather hadn't helped us either, because now what we are doing is staying overly wet too long. A lot of moisture on leaves, a lot of moisture in the ground that's not going away. And we need moisture, but not this much. And the problem is, if you step off, and you'll have a chance here, this particular variety right here, 18RU, one thing that we watch with it is late season leaf spot. It's not like 13M. If anybody grew 13M a little while back, that is very, very susceptible. This one is not that bad. It's worse than 06. But if you walk out here now, we're already losing about 10 to 20% of the foliage because of early leaf spot. And so that's a problem. And we may say it's this variety, but what has this rain caused us all over the state to be, for the most part? Behind. We have still got growers that have only, we're 75, 80 days that have only received one fungicide application. Some of them two. Some of them have been able to stay on with airplanes and keep that schedule going, but we got a lot of places that have not. And so if you're on a program that has where you couldn't get in there on time or you missed a spray, we need to be in the field right now looking. And I know Peyton and them are going to talk about the fungicide programs, but the biggest thing that we need to make sure of is know what we have in the field. And so if you are using programs that don't have curative activity and you got leaf spot like in this particular variety right here, then we've got some issues that's going to develop very rapidly. And so know that white mold is definitely coming about all over the state right now. This heat is going to run that pretty quickly. So hopefully you got a crop scout that's taking a look at that. Other things that we just want to mention real quick is the maturity of this crop. As we go forward, we have looked at some so far that are around last week. They were 132 days old, it looked like, based on the board. The perfect profile so far with all the rain. It looks like we're going to be about 148 to 50 days on that first round of early April planted. That's not anything unusual. But keep them picture here, if you got dry land and you got irrigated, for the most part in a normal year where we have dry periods, we do see the dry land take a little bit longer sometimes. Sometimes it speeds it up. This year, I think our dry land and irrigated are going to be right there together. So if you got fields planted at the same time, make sure not to ignore that other field or that non-irrigated field. We need to start looking at them at 120 to 125 days to start looking at what this particular crop looks like. Take them to your extension agent and let's start putting them on the board and see it. You may be a ways out, but at least it'll give us a chance to look at it. Heat units, we are a couple of hundred heat units behind. That's what I mean. It's been a mild year so far, so we need to watch that. But this big thing here is if you're growing some of these varieties, even 06, and you have not used good fungicide programs or have missed some sprays and you got at 110, 120 days and you got leaf spot real bad, please get on the phone to your agent and talk to Bob, and let's try to formulate a plan to try to mitigate some of this. We're not going to slow it down completely or eliminate it, but we need to know, do we need to be ahead of the game if we need to make some decisions on maturity or digging early. With that, that's all I've got. Where's Wade at? There he is. I'm going to let Wade talk about the varieties and what we got here.
Thank you, Dr. Mumford. Good to see everybody today. Before I get started, I just want to thank you all for attending the Midville Field Day this year. I know it's hot. I know there's no air blowing, but at the same time, it's like that pretty much every year. I think one year it rained so hard that we had to stay at the shelter till about 10 o'clock, but that's not the case today. However, rain has been the topic of discussion this year, especially in Jenkins County and a lot of Scriven County. And Bullock, there has been days where it has rained and rained and rained every day. And so that has really been a force on our crop. When I walked out here a few minutes ago, when we started, it's very, very wet out here. And that's from rains, and I think Anthony also irrigated a couple of days ago. But just a few comments about the variety trial here. The collaborators are myself, Dr. Mumford, and Stephen Powell over here. Stephen is the ag agent in Truitland County. And if you don't know me, I'm Wade Parker, and I work in the district office, and I'm also covering Jenkins County on an interim basis as an ag agent. But what we got is we got 6 varieties. It was replicated 4 times, starting right here by the flag and going all the way to the end where you see the flag. So each variety is planted 4 times out here. Our planting date was May the 14th, and the fungicide program was pre-Axer and a convoy-based program with Bravo and Tebs mixed in the regime. And the herbicides are just standard UGA recommendations that we follow, and the seeding rate is 140 pounds to the acre. But anyway, just a couple of the highlights on some of the varieties. Dr. Mumford's already mentioned some of them, but starting over here, the first 2 varieties, 20 VHO and 18 RU. The VHO is a high oleic, high yielding spotted wilt resistant variety, and the next one is just a normal oleic. Well, one thing that I noticed about both of these varieties is when we did stand counts, they were a lot more vigorous as far as coming out of the ground, as far as growing, than the rest of them. So that's something that I noted, is the vigor seemed to be real good. And these varieties, you know, we hear about more peanut varieties available, but at the same time, what's the major issue we have when it comes time to planting, if we're not going to plant the 06G, is seed supply. So some of these varieties will be available more next year, especially the Georgia 16HO. Okay, moving on down the line, Georgia 12Y, that's been on the market a while, and the Georgia 12Y, a couple things about it. It is extremely white mold resistant. But one of the things we need to keep in mind with the 12Y is the maturity range on it, as far as days, is 160 to 170 days. So that's a considerable difference between that and 06G and the rest of these out here that run between what's got 140, 145. So the 12Y is considerably later. And rhizoctonia susceptibility. Okay, the AUNPL 17, that's a Auburn variety, is high oleic, spotted wilt resistant, and there's not been a lot of seeds available for that, but that should go up next year. Then, of course, on the very end is our standby 06G. So when we hear about peanuts in Georgia, what do we hear? Georgia 06G. And that is approximately 85 to 86% of the acres in the state of Georgia. And 06G, as we know, is probably 140, 145 days of maturity, large seeded variety, and spotted wilt resistance. And overall, it's done a very good job for us in Georgia. So, Dr. Mumford, can you think of anything I missed? Oh, one thing I want to point out, I don't know if he did, but the VHO, if you'll look, and we're going to walk around the plots in a minute, you can see that it's a lot lower growing. It's very distinct. It's not as stout as these other varieties. It's a little bit more dwarfed. So that's a characteristic that's pretty unique of it.
But it did very well over here compared to 06.
It did. It did very well over here compared to the 06. So that's going to be interesting to see how this turns out.
How much better was it?
All right, guys, good morning. As you can tell, I'm not Dr. Kimmerite. He is unfortunately in Guam right now. My name is George MacDonald, and I'm an intern from the University of Florida. I'm in my senior year of my plant science degree, and since Dr. Kimmerite and Casey couldn't make it here today, I'm here to talk about the importance of research and extension up here at Midville. So a big problem in Georgia is rust, and to help combat this problem, Dr. Kimmerite has been looking at sentinel plots all over the state of Georgia for over 10 years now. Oh, right there? Okay. Oh, okay, here we go. Yeah, he's been looking at sentinel plots for about over 10 years now in Georgia. Just this year in Midville, we were able to find southern corn rust on July 7th and soybean rust on July 27th as well. The importance of finding the rust in and around Midville is it allows us to give our recommendations to the growers of East Georgia. We can recommend our very best fungicide applications and let y'all know if fungicides are necessary throughout the growing season. Another relatively new problem that we were facing, especially in cotton, is the cotton leaf roll dwarf disease. We have plenty of sentinel plots set up that are monitoring for this disease. Luckily this year we haven't found any. We hope to kind of keep it that way. Another important factor about Midville is it allows us to view a different disease spectrum in peanuts than what we're used to. So down in southwest Georgia, where the majority of our field trials are, we see a lot more leaf spot pressures, while up here we're seeing more white mold and CBR pressures. This year, if you guys want to go ahead and take a look right over there, we have a couple of different trials going on. We have one trial from BASF and one trial from Corteva. Each of those trials are testing new fungicide application strategies to determine their effectiveness on common peanut diseases. Before I go ahead and hand it over to Peyton to talk more about peanut fungicides, Dr. Kimmerite wanted me to go ahead and thank Anthony and all the staff out here for having a great farm and letting us work out here. Thank you.
Thank you, George. Appreciate everybody being here, and I'll say up front again, thanks to Anthony. I always appreciate the collaboration. I feel like he tries his best to take care of extension agents, and he says he does anyway, and he says it's because we're out there face-to-face, kind of on the front lines. That may be a line from Wade, but again, it's a wonderful thing to have this opportunity here on the station. Hopefully, as growers, you value that as well. Wanted to do a couple of things. So George pointed out the fungicide trial that's behind you. So we try to take a very similar set of fungicides and recommendations and apply it on a larger scale, if you will, so that we kind of have some of the same pressures you would have in your field here on the station as we're looking at them. So Dr. Bob, he sends those different fungicide regimes out to agents, and you kind of can pick the ones you can fit. So this year, out of 11, we were able to fit 6. Out of those 6, we'll, as Wade said, we'll share results and stuff from this year, next year, or during the grower meetings that we have this fall and winter. What I did do in your booklet, if you picked up the booklet that Anthony put together for you, we have the results from the 2020 trial, so we had a little bit different set of fungicide treatments, but really rather than go over the exact numbers, I just wanted to remind you of some things. I think Bob would do the same if he was here. First of all, what's he going to say you have to know? What do you evaluate at the beginning of the season before you ever put the seed in the ground? Risk. He's going to say, what's your risk? So if you have a variety that's extra prone to leaf spot, incorporate that into your program. If you're tightening up your rotation, incorporate that into your thoughts and behind the program you choose. So that's one thing. When you look at those results that are in that booklet from 2020, I'd rather for you not to, as a grower, go all the way to the end column where it talks about yields. At least don't do that at first. Every grower here is going to do that. But the reason I say don't is I think the other thing that Bob's going to talk about is he's going to talk about timing, right? He's going to say risk, and he's going to talk about your choice of fungicides associated with that, and he's going to talk about timing. Scott already said it. Our timing in a lot of cases is off a little bit this year. If you're still if you come to your county agent and you say, well, I did what I've always done, and I got problems this year. That fungicide's not working as good. Maybe it is and maybe it didn't. Maybe it's your timing. So anyway, think through that as you're looking at the results from last year. You go down through there and you look and see, if you look at the untreated check that we had last year, the average leaf spot score was 3.83, which is significantly higher than the rest of the fungicide programs. And then your average white mold score was a 5, which was, again, way higher than the majority of the fungicide programs. So we have good fungicide programs out there. There's one that'll fit you and will help you. Know how to shift gears. Scott mentioned, check with your agents, have somebody looking in your fields. If you're not doing that, you're making a mistake. Let's see what's out there. Let's shift gears. Let's customize that program to fit what you need to fit today. The only other thing that I mentioned to the other group, or that I brought up, and maybe I'm being a little preemptive. I'm thinking ahead. But next year you're going to look and you're going to say, well, wait a minute. The 2020 programs were, let's say, 3 blocks of Fontellus and, maybe Teb Bravo or chlorothalonil, tebuconazole on either end or something like that. It was a one company's program and no other actives. If you look at this year's sheet, if you look at the programs that we have in the large block study this year, you'll see some combinations. Why is that? Just for fun? All right, so if you believe that resistance is real or could be real, then that's maybe why we're doing it. If you don't believe it, it don't matter. Don't worry about what I just said. But, okay, so I think that we're starting to look as an industry, as a group, at resistance issues. We're realizing that they're real. They can be a problem. And then we're still kind of focused in on management and making it right? So make sure what you did didn't cause a problem. But next year's trials, the results to me are going to be interesting because I just see some combinations that are interesting to me, and we'll see what happens as far as disease pressure. I don't really have anything else. Scott, do you have anything you want to add? You want them to look through have a chance to walk through varieties here or something? Oh yeah, I was going to ask you what's early. You said don't plant early and don't plant late, right? As in regard to varieties. So what's early in Tifton and what's late in Tifton?
Well, we shoot for the first part of May in Tifton. That's normal. That's normal. But we're planting some April stuff in Tifton too. 12Y. We talk about that one, and most of y'all might have heard it was 150, 160 day peanut, if not longer. And you almost write it off automatically, right? Because you don't want to plant that late of maturity. Guess what? We put a limit on that one. If you're going to plant it, that's an April planted peanut through about May 12th. If you can't plant it before then, we don't recommend you putting it in the field at all because you're not going to get the yield potential out of it. So that's one thing to know on that one. But it will hold the pegs a lot better than most varieties too. So that's why it can go out that far. The other thing with the maturity I didn't mention, we got behind with weather. What else did we get behind with? Most of our weed management programs, and we had to use some pretty harsh stuff on a lot of a lot of our acres. Gramoxone, which we typically use in a lot of areas, but we don't always use it. But we had to use a lot of other stuff to try to help clean up. That also set this crop back a little bit. So don't get hung up on days after planting. That is something we need to make sure. Let's look at them on the board, and when you go and get that sample out of the field, don't just get it in one spot. Let's get it from all over and try to make the best judgment we can, because it could be that we're at 150 days, and that may be our average this go around, because we've had quite a few things set us back. And I don't think we've pushed 95 degrees very much to push this crop, or even 90s, really. This is about the hottest day we've had in a while. So just keep that in mind. And that's what I don't want people to get locked in on. Days after planting doesn't necessarily mean anything. It's the crop itself. It's when we started blooming. And if we had to set it back with gramoxone, that could be 2 weeks there that we have to look at. So please keep that in mind when we take care of this. And every field is going to be different. Just because this one started out at 140 and you planted the fields down the road at the same time, you may be a 10-day difference depending on what you got. So soils and rain, irrigation, that kind of stuff. So just keep that in mind. But yeah, if you want to, get out and look around. If they got a few minutes, let them look. If you want to look through the varieties, you can. The biggest thing to note, like I said, is in this variety is a lot of leaf spot. So if you hadn't seen leaf spot before, it's a good chance to see it. It is early leaf spot. If you hadn't seen that, you can pick up the leaf spots on the bottom middle of the canopy. If you pull those, you're going to see kind of white crystals in the spot, and that's leaf spot. That's why we say we see those spores germinating. We do have a lot of chemical injury out here as well, so you got to know the difference, and a lot of those being mid canopy to the top. So keep that in mind as well. Any other questions, comments?
Real quick, microtile disperse. Heard some people talk about it. I don't know much about it. I'm missing out.
So microthiol dispersed is something that the pathologists have worked quite a bit on lately, looking at trying to add efficacy or control of some of the older fungicides. So like your Abound, your Headlines, tebuconazole, and even maybe some of the newer stuff. But we know with some of those that sulfur, that microthiol sulfur in there will increase the efficacy of that, or the control of that particular product. Sulfur is somewhat fungicidal anyway, but the thing about the microdispersed is it does not tend to burn the crop. If y'all remember back what the liquid sulfurs we put out, they tend to burn, especially when you mix with some things. That's why this one works. If you use something like, what's an example? Is it Tiger 90 or Tiger something that is a kind of a more coarse type sulfur? Even though it'll mix, it's pretty coarse, it's not ground, it'll burn the crop. And so you got to work on that. Everything that they've seen so far is a lot of these microthiol type dispersed sulfur products. Some of them might be. That's a little bit, I'm not as up to speed on that 100%. It's not, yeah, I don't think it. But any other questions, comments? All right, that's all we got.
Okay, if everybody's ready, we'll go ahead and get started. This, I think, is the last stop before lunch, I believe. On this stop, we'll talk about the cotton variety trial. In the statewide cotton variety trial this year, we've got 12 different varieties. Here at Midville, we've got the irrigated trial here. At the other end of the peanut field, we've got the dryland trial down there. Again, there's 12 varieties this year. I've been working this trial since, I believe, 2015 when I started, and every year is constantly changing. We're adding new varieties to the mix, bringing on the new traits, everything, and constantly changing and evolving. This trial, when we think about the impact of this trial, if we can calculate the number of acres, cotton acres that we have in a county and figure that up, if we can increase county yield by 10 pounds, think about the economic impact we can have from this statewide cotton variety trial. This year in the lineup, another thing I want to mention is how big this trial is. It's not a small plot trial. These rows are probably 900 to 1,000 foot long, so this is not a small trial. So this is very, just like it will be on a farm, that kind of thing. And we can get the side-by-side comparisons. Each set, each variety is repeated 4 times throughout this trial, and again, it's repeated across this way, across the field, and repeated 4 times. Involved in this today, we have Camp Han and Miss Pam Sapp are the other ones that are working with me on this. And going into the different varieties, this year we have 3 Delta Pine varieties. We have 2 Stoneville, 2 Phytogen, 2 Next Gen, 2 Dynagrow, and 1 Armor variety. As far as the herbicide traits, we have 10 of them are Extend, which can be sprayed with Roundup, Liberty, and Dicamba. 2 of them are the Enlist varieties, which will be Roundup, Liberty, and 2,4-D choline. Going into the insect traits, we have one of them being 1646, which is Bollgard 2, and then everything up from there would be the 3 gene insect traits.
We have 9 of them being bow guard 3 and 2 of them being wide strike 3. So at this point, I'll turn it over to Miss Pam, which will talk to us about the management of this particular plot and what's been done as far as managing.
So as you can see, am I doing it right? There we go. As you can see, this has been planted into some pretty heavy rye cover. Looks really good this late in the season, so Anthony's doing a great job on managing that. This particular trial was planted on May the 7th, and as far as he put about 80 units of nitrogen on side dress, besides what he puts in on his spreader, and then 13 units of nitrogen at lay-by. Pest management, it also has about 18 ounces of vellum, came back with acephate application, and it's had 6 ounces of Bidrin. Weed control, so of course glyphosate burn down. One application was diuron, reflex, and gramoxone. The next one glyphosate, Liberty, and Warrant. And then a glyphosate Liberty application. And then at lay-by, diuron, MSA, and Invoke directed. Irrigation is, we've all had a pretty rainy season. It's had a total of 3.35 inches, most of that coming in May on the irrigation. And it's only had 2 shots of Mepiquat so far, 16-ounce applications, and then boron at 3 apps on here. So with that, if you have any questions afterwards, we're going to take some time to walk through the plots. We'll be glad to answer any questions, and I'm going to introduce our new cotton agronomist that I feel like most of you probably haven't met yet. Some may have, but Camp Hand, he started back in February when we couldn't have meetings, and we're glad to have him here, and I'll turn it over.
All right, thanks, Pam. Like Pam said, my name is Camp Hand. I started about 6 months ago here at the University of Georgia. Glad to be here and proud to be at the University of Georgia and be the cotton specialist here. I want to thank Anthony and the crew here at Midville. They do 2 trials for us every year. Last year, they were 2 of our highest yielding locations, and kind of like Pam touched on, with the rainfall we've had, it's been very timely rains at critical periods in our cotton growth, and so I would expect that these are going to be 2 of our higher yielding locations this year as well. Kind of like Jason was saying, the value of this program just cannot be overstated. I think we calculated it just for his county. If somebody booked at 90 cents, which by the way, I saw that cotton hit 92 this morning, and so I would encourage everybody to book just a little. But if you calculated the impact his trial has on his county, if you improve lint yield 10 pounds, you're talking about $250,000 just in Screven County. And that is a huge impact just in one county. And this trial is conducted in 24 locations across the state of Georgia, ranging from Seminole County down in the very southwest corner, even up to Athens and the J. Phil Campbell Research Station just north of here. So, as I mentioned, it's just a huge impact. This program has a huge impact on our state and on cotton production here in Georgia.